Okay, good morning. Welcome back to trigonometry. This is the identity parts of the problem, or we're looking at problem number three. This is 3a. Um, there's only going to be three identities, I think. There's only going to be so many. I'm not going to put A through N on your final. You have like two, three, maybe, yeah, maybe four identities, but I think there's three identities. So we're going to try to prove this. Now, the thing with identities is you are only allowed to work on one side at a time. Okay, you can't, this is not an equation. You're not trying to set these equal to each other and solve. We're not doing that. It's solely the left side equals the right side, or you can start on the right side equals the left side. There's not a lot to do on the right side. I don't want to start there. I'm going to start on the left side. So we're going to remember that sine squared plus cosine squared is equal to 1. And we're going to go ahead and divide everybody here by cosine squared. So we have a tangent squared plus 1 is equal to secant squared. Okay? So at this point, we're going to say, hey, wait a minute. Tangent squared is equal to secant squared minus 1. Okay? So we'll go ahead and we'll do that. So instead of looking at this, we're going to say this is going to be 2 times secant squared minus 1. We're going to say we have a 2 times secant squared. Did I write this down right? Oh, there's no 2 there. It's just secant squared. Okay, that's it. So let's go ahead and fix my problem because I miscopied it. So I'm looking at my copy here. You guys can see this better than I can, but let me blow this up just so we can see it. But see, it's just a secant squared. All right, we'll go ahead and fix that. So we have a secant squared minus 1 up here. We know that secant squared minus 1 is actually equal to tangent squared. Okay, so that's tangent squared A divided by secant squared. And we're going to say what that equals to. So I'm going to go ahead and divide this fraction into two pieces. I'm going to say this is going to be tangent squared of A times 1 over secant squared, just to kind of break that fraction up into two different spots. Okay. Well, 1 over secant squared is actually cosine squared A times, and we have tangent squared here, so that's sine squared over cosine squared, and then we'll figure out what's happening with that. So at that point, we could say, hey, let's go ahead and cancel off these cosine squareds. So we have sine squared A, and what was I trying to prove on the right-hand side was sine squared A. So the identity is proven. Okay, again, you're only allowed to work on one side. These are not equations. These are proofs. These are identities, but we're not trying to solve this thing. We're trying to prove it. Sometimes some books lie to you and they give you identities that don't work. Your book is not one of those books. They do not lie to you. All of the problems are actually true. Okay, so putting it as like a true false problem would be kind of silly. So this one, 1 over 1 minus sine plus 1 over 1 plus sine is equal to 2 sine theta. So is equal to 2 sine. Yeah. So we're going to go ahead and write down the problem. So we have 1 over 1 minus sine theta plus 1 over 1 plus sine theta. And we're claiming that's equal to 2 sine of thetas. Okay, double check to make sure I write down the problem correctly. Yep, we're good. So we'll figure out from what happens here. Well, on this problem, we have two fractions. Maybe we can try to add them. So I'm just going to go get common denominators here. 1 plus sine theta over 1 plus sine theta. Over here, I'm going to move this equal sign a little bit further. Okay, so we have 1 minus sine theta times 1 minus sine theta. And we're just adding the fractions to see where this takes us. So we have 1 plus sine theta on the top here. Okay, it's going to be one giant fraction because these are both common denominators, I can tell. And we have plus 1 minus sine theta. Now on the bottom, we got to FOIL this out, but that's the difference of squares, or this is a conjugate pair, so we're just going to have 1 minus sine squared theta. Okay, and yep. Did I write this down wrong? No, I'm okay. Oh, you know what? I bet I did write it down wrong. I'll bet it's a secant. It's supposed to be a secant. We'll fix this on the problem for you guys so we can say it's 2 secant of thetas is what's going on here. Okay, we've messed that one up. So we'll go ahead and we add these together. The signs cancel, so we end up with 1 over 1 minus sine squared, that's going to be cosine squared. Actually, we have 1 plus 1. It's going to be 2. 2 over cosine squared. That is equal to 2 secant squared theta. After I make this correction, and I will make that correction for you guys, that'll be the same thing. So this one I did lie to you, but that was more of my problem rather than the book's problem. So it was supposed to be 2 secant over here. So we'll do that as a correction, and we'll make sure that that one works for you. Okay. Next one, problem number C, we have secant theta plus tangent theta. Okay, so here we go. We have a secant theta plus tangent theta equals, and then what do we have here? We have, this is secant theta, cosine over 1 minus sine. So we have cosine theta over 1 minus sine theta. Okay, double checking, double checking. Very good. Okay, so here we're going to go ahead and say this is 1 over cosine theta. Okay, there's a couple of different techniques you can use. One of the techniques is change everything to sines and cosines and hope for the best. Okay, all right. So here we have 1 plus sine theta divided by cosine theta. That's not quite what I'm looking for. So what I'm going to do is I'm going to multiply both sides. I'm going to multiply top and bottom by cosine theta over here, cosine theta over here. Okay, because I'm looking for cosine theta. The other things you can do is like, well, I could multiply by 1, or you could add 0. Those are the only two math tricks that we have here. So we have 1 plus sine theta divided by, or times cosine theta, okay, divided by cosine squared theta. Well, we know that sine squared plus cosine squared is equal to 1. Therefore, cosine squared must be equal to 1 minus sine squared theta. Okay, so we're going to go ahead and break this cosine down into, we have 1 plus sine theta times cosine theta. There's other ways to do all of these, by the way. Just because I did it this way doesn't mean you have to. It doesn't mean that you're going to see it a different way. It's all fine. Okay, so we're going to end up with 1 minus sine squared theta, which we could say is 1 minus sine theta, 1 plus sine theta. And we're going to go ahead and break this down into this. We have 1 plus sine theta times 1 minus sine theta. Okay, and then we can go ahead and cancel some stuff off here. So we end up with cosine theta over 1 minus sine theta. And if I look at what I started with and what I'm supposed to end with, this is what we were supposed to end with. And we're going to call that a good identity there. Okay, so that was problems A, B, and C. So with that, we'll do a couple more in a moment. But thank you very much for watching the video, and we'll see you in the next one. Take care.